Okay, good day, everyone who is watching. This lesson deals with area and perimeter of 2D shapes, right? So first, let's understand what is area and what is perimeter. And let's not confuse the two, right? So perimeter has to do with the total distance around the shape. So it has to do with the total distance around a shape. So I like to think of perimeter as the length of fence that you place around a polygon or a shape, right? Whereas area tells me how much of space is covered in that polygon. So it's basically the number of square units that will fit inside the polygon. So what's covered inside the shape? Covered in the polygon. That's the area of that polygon in just simple layman terms. So now let's first start off with the area, right? Let's start off with, oh sorry, before we start off with the area, let's start with perimeter. Let's say I have a square, right? Let's say I have a square, assuming this is a perfect square. We know the properties of the square when we looked at the properties of quadrilaterals, right? We know that all sides of the square are equal to each other, and the interior angles or the corner angles are equal to 90 degrees. Now, to calculate the perimeter of the square, let's assume that one side of the square is S, which implies that every single side of the square will be S. So the perimeter is basically equal to S plus S plus S plus S. All I do is add all the sides of the outside of the triangle. I do not include any lengths inside. So even if I include a diagonal inside the square, for example, I will not include that in the perimeter because I am only adding the sides that is outside of the shape. So S plus S plus S plus S, those four terms are like terms. So the perimeter of any square is 4S. If I look at a rectangle, right, I know that both pairs of opposite sides of a rectangle are equal to each other. Both pairs of opposite sides of a rectangle are equal to each other. The corner angles are equal to 90 degrees. If this is the length, we have the breadth. This will be the breadth. This will be the length. So the perimeter is equal to length plus breadth plus length plus breadth. And when we add the like terms, L plus L is 2L plus B plus B is 2B. That's the general formula. Or we can factor out the 2, and we have 2 into L plus B, right? And then we have the circle, right? Now, I can explain the circle to you, right? So if you want to calculate the perimeter of the circle, it involves pi. And pi is basically the ratio between the circumference of the circle and its diameter. So for example, pi is basically the ratio of the diameter, the circumference of the circle, c, over the diameter. So that's what pi is, circumference over diameter. And if I want to make circumference the subject of the formula, I need to multiply both sides of the equation by that diameter. So what do I have? So I have that pi is equal, pi d is equal to the circumference. So the circumference is equal to pi d, pi times the diameter. So let's understand these terms. The diameter is the line segment of the circle that starts from one point on the circumference. It goes through the center of the circle and it goes to the other end of the circumference. Basically, it starts on one point on the circumference, it goes through the center of the circle all the way to the other side of the circumference. It's a line segment, if you will. The radius, basically, now what I've just drawn now is the diameter. The radius is basically half the size of the diameter. What is the radius? The radius is the line segment from the center of the circle all the way to the circumference of the circle as such. So that is the radius. And the relationship between the radius and the diameter is that the radius is half the size of the diameter and the diameter is twice as large as the radius. So I can rewrite the circumference formula as circumference is equal to 2 pi r. Now why is it 2 pi r? Because d, the diameter, is 2r. It's 2 times r. It's double the size of r. And lastly, if you look at a triangle, the perimeter of a triangle, I'm going to be quite quick on this one because it's quite simple, right? If I look at a triangle, and we know that triangle has 3 different sides, depending on the type of triangle it is. An isosceles triangle, all 3 sides will be equal to each other. An isosceles, 2 pair of sides will be equal to each other, or 2 sides will be equal to each other, and a scalene, no side will be equal to each other. But either way, the perimeter of a circle, of a triangle, is A, the length of one side of the triangle, plus B, the other side of the triangle, plus C, the last side of the triangle, right? And that is how I calculate the perimeter of these, the different types of polygons that we have. Now, if we look at area, before we look at an example, right? If we look at area very quickly, right? If we look at area, let's look at the area of a square. So let's start off with the area of a square. Now, the area of a square is basically, if let's say this is 5 units, this is 5 units, 5 units, 5 units, 5 units, just as an example, 5 units and 5 units, right? So that means all, this is a square, so all 4 sides are equal to each other. The interior angles are equal to 90 degrees each. Now, if we want to calculate the area of the square, we have to determine how many small squares, like very small squares, how many small squares of 1 unit by 1 unit can we fit inside this 5 by 5 square? And the answer is, you can literally do that, and the answer is 25 units. Now, how do we calculate the area of a square? We can just take one side and multiply it by the other side. So it's side times side. So the area of a square is equal to side times side, which we know from the laws of exponents, side times side is side squared. So if you want to calculate the area of this square, I'm going to say 5 squared, which is 25 square units. And do not forget, units is area is always square units. So if it's in centimeters, it's going to be centimeters squared. If it's in millimeters, it's going to be millimeters squared, etc. Right. And moving on from there, let's look at a rectangle. A rectangle, the same procedure applies, but however, with a rectangle, right, all the sides are not equal to each other. We know that both pairs of opposite sides are equal. So the rectangle, the area of a rectangle, so the area of a rectangle is equal to length times breadth. It's the length multiplied by the breadth as well. If I look at a triangle, here before I go on to the circle, okay, let me get that right. If we look at a triangle, we have a base and we have a height. Let's assume this is the height. The height is always perpendicular to the base of the triangle. Perpendicular means that there are 2 lines or line segments that intersect at an angle of 90 degrees. Okay, let me get that right. Try to draw a nice straight line here. Okay, so they intersect at an angle of 90 degrees. So it's a perpendicular. It's perpendicular because it's 90 degrees point here. So what is the area? So we have the height, and the base is this entire length here, which is the base. So the area of a triangle is equal to half base times height. And sometimes you might be required to use Pythagoras because this is a right angle triangle and this is another right angle triangle. Do not forget the theorem of Pythagoras states that the hypotenuse squared is equal to the sum of the square of the other two sides. Very important that you know that as well. Now, you also get a triangle that looks like this, right? A right-angled triangle. Now, the right-angled triangle, I notice some learners get confused with this, but again, the base, if this is, for example, the base, the height is always perpendicular to the base. So from this perspective, this is the base, this is the height. If I rotate it around, this could be the base and that could be the height. So the order doesn't really matter in this case, but the area will still be the same. It's half base times height. That's the height that we have there. Now lastly, we are moving on to a circle. Right, we are moving on to a circle. So let's see what we have. So with the circle, there's an entire investigation I would have gave you in class where if we separate this circle into segments, into equal segments, for example, 8 segments. A segment is like a slice in a pizza. So if we separate it into segments and we put one up, one down, one up, one down, it will eventually appear to look like a rectangle, but it has arcs. So if instead of cutting 8 equal slices of the pizza or 8 equal sectors, we now cut it up into 16 sectors. And instead of 18, 16, we now make 32. And instead of 32, we make 64. Instead of 64, we make 124, etc. So eventually, you're going to get a perfect rectangle. And using that long investigation, we can just conclude that the area of any circle is pi r squared. Right, so that is the area of a circle. Now, let's look at some examples of past year papers and the questions that they ask you for this particular section. So I think it's actually quite interesting that we look into that now. All right, so let's look at a couple of examples. Right, let's look at example 1. Right, so example 1. For example 1, we have a circle that looks something like this. Right, apologies that I have to draw this now, but nevertheless, let's see. Okay, so I have a shape that looks something like this. Right, let's say all of this is taken out. Okay, so I have something that looks like this. Oops. Okay, so we have something that looks like this. So let's see what we have. So we have a shape that looks like this, and the question reads, I actually found this question from a past paper. It says the diagram, right, the diagram, it represents 3/4 of a circle. Right, so it represents 3/4 of a circle. The diameter, remember the diameter is a line segment. Diameter, it's the line segment that is starting from one point on the circumference and goes through the center of the circle and ends on the other side of the circumference. Right, diameter of the circle is 30 centimeters. Right, what is the area of the figure? Okay, so we have a figure that looks something like this, and we need to calculate the area of this figure. Now, we're also given that this is 90 degrees. So this implies that this point is the center of the circle. If I look at this, the question states that it is 3/4 of a full circle. So originally my full circle looked something like this. If I can draw that slightly better, that would be great. It looks like a full circle. It looks something like this. I just added the red part to show you the full circle, right? So what I'm going to do is I'm going to first calculate the area of the full circle. So I'm going to say area of full circle. Let's say area of full circle. We know that the area of any full circle is pi r squared. That's the formula that we use, which is equal to pi. The diameter is given to be 30, but I know that the radius is equal to half. The radius is equal to half the size of the diameter. So it's half of 30 centimeters, which is of course 15 centimeters. So the radius is 15 centimeters. So I'm going to substitute 15 in the place of r squared, and that is equal to, let's see what that is equal to. That is equal to squared, that's 225 pi centimeters squared, because it's area. I'm not going to round up now. I can round up my final answer. But now we do not need the area of the full circle. Why? Because I just added these red dots myself. We need the area of this quarter circle here. That is the area that we need of this entire quarter circle that I'm shading in with blue. So the area of the not quarter circle, the area of the 3/4 circle, actually. This part is a quarter circle. So the area of the 3/4 circle is equal to 3/4 times the area of the full circle, which is 225 pi centimeters squared. And that is equal to 3/4 times 225 pi. I'm going to press SD on my calculator. That is 530.14 centimeters squared. And I decided to round off my final answer to 2 decimal places. Please read the instruction in your test or exam to tell you by how much you should actually round off. Right. That was example 1. Let's move on to the next example. For the next one, we are required to find the area and the perimeter of this complex or compound shape. And it's called a complex or a compound shape because it's a combination of 2 or more other basic shapes that is combined into one shape. So what do I mean by that? So let's say I have a shape that looks something like this. Right, let's say I have a shape that looks something like this. And I have a shape that looks something like that. Trying to draw this shape on the spot as well. Okay. Yeah, okay, that's fine. Now let's draw another semicircle here. Okay, so we have a shape that looks something like this. Now, of course, they may not include these parts here, so let me just take that out for you. Right? Let me just remove that. Okay. So you're basically given a figure that looks something like this. Right. Okay, so you're given a figure that looks something like that, and of course, might be given that this is a straight line there, and then there's a straight line that doesn't look straight at all. Let's assume there's a nice straight line there, and this is 90 degrees. 90 degrees, this has to be straight. 90 degrees, 90 degrees, and We are also given that this length from this point all the way to this point, we are given that this is 102 meters, and we are given that this entire length, meaning this length that is inside here, we are given that that is 60 meters. Now, question 1 states that we need to find the perimeter of the shape. Perimeter basically means we need to go around the shape, right? So we need to go around the entire shape. So what I'm going to do is I'm going to calculate the circumference of the semicircle that is here, the semicircle that is here, and I'm going to add it to this side and this side, because this is a rectangle, by the way. This is a perfect rectangle, and these two sides, this is a semicircle, this is another semicircle. Now my question is, if I have, and there's no need to include the outside as well, because the definition of um, perimeter is that it is only the outside of the shape. Now, if I look at this question very carefully, right, I have a semicircle and I have another semicircle. If I join it together, it's going to give me one complete circle, right? So I'm going to say circumference of circle, right? Because remember, two semicircles gives you one complete circle, and that is pi d, right? And the diameter of the full circle will be 60 meters, so it's going to be 60 pi meters. So that's 60 pi is basically this part combined with this part. So this is 30 pi, right? Because it's a semicircle, and this is 30 pi. When I say this, I'm referring to the circumference of these semicircles. Now combined, this length, this curve plus this curve gives you 60 pi. Now let's include the 102 meters that is here and the 102 meters that are at the bottom as well. So what do we have? I'm going to say perimeter of what is this, of the figure. It's equal to 60 pi, which is 30 pi plus 30 pi, plus 102 meters plus 102 meters. So technically what I did, I said 30 pi plus 102 plus 30 pi plus 102, and that will give me the perimeter of the shape. So it's 60 pi plus 102 plus 102, and that is equal to, if I round up to two decimal places, 392.50 meters, and that is my final answer. Now, to calculate the area of this figure, it's very interesting because this figure is actually made up of three shapes. It's made up of a semicircle plus a rectangle plus um, another semicircle. That is the same, this semicircle is the same size as this semicircle. So let's calculate the area of an entire circle. Why? Because the area of this semicircle, which I'm shading in blue, plus the area of this semicircle, which I'm shading in blue, will give you the area of one complete circle. So let's do that. So we have the area of a circle is equal to pi r squared. So this is question 2 of calculating the area of this particular shape. It's equal to pi multiplied by the radius. Now, I know that the length of the diameter of the circle is 60 meters, so the radius will be half the size of 60, so that's going to be 60 pi, which is equal to, and let's calculate what this is, that's 3,600 meters squared, because we're dealing with area. And remember, that is basically the area of the semicircle plus the area of this semicircle, C, and that's what we have. Now let's calculate the area. Right, let's calculate the area of the rectangle. So I'm going to say the area of the rectangle is equal to length times breadth, which is equal to the length is 102 meters times the breadth, which is, as we established, 60 meters. And what does that give you? That will give you 6,120 meters squared as such. So what is the area of the entire figure? What is the area of the entire figure? So the area of the entire figure, right? The area of the entire figure. The area of this figure is equal to the area of the circle, which is 3,600. So this should be pi, right? So I'm sure you screaming at your screen and saying, why is it 3,600? So it's 3,600 pi. So please forgive that mistake. So it's 3,600 pi meters squared plus 3,600 pi meters squared plus 6,120 meters squared. And now I can add these two together, and that gives me 9,720. Sorry, no, that is incorrect. I'm always forgetting pi for some reason, and you cannot forget pi at all. So that gives you, let me just correct that. And that gives you 17,429.73 meters squared, and that is my final answer. Okay, thank you for watching this video.